Conference on smart innovations in engineering and technology. On behalf of the management, the principal, and the entire fraternity of NPR College of Engineering and Technology, I extend to this scholarly congregation.
Every noble beginning seeks divine grace. To invoke the blessings of
Respected dignitaries, for illuminating this occasion with all your presence.
the essence of any successful gathering lies in the warmth of its welcome. I now deem it a great honor to invite Dr. M. Amina Banu, Head of the Department of Electronics and Communication Engineering and Convener of ICSIET 2026 to deliver the welcome address.
A very pleasant morning to one and all. It's my immense privilege and profound honor to extend a warm and gracious welcome to all the distinguished dignitaries, eminent keynote speakers, respected session chairs, esteemed faculty members, researchers, and dear students gathered here for the International Conference on Smart Innovations in Engineering and Technology ICSIET 2026. This prestigious international forum, organized in hybrid mode on 28th and 29th of April 2026, serves as a dynamic confluence of intellectuals, academicians, industry experts, and budding innovators to disseminate knowledge, present, pioneering research, and deliberate on emerging technology frontiers. In this rapidly evolving technological landscape, smart innovations are redefining every sphere of human life, from advanced industrial systems and intelligent infrastructure to sustainable development and digital transformation. ICSIET 2026 aspires to catalyze insightful discussions and foster collaborative endeavors that address real-world challenges through cutting-edge engineering solutions. It's my proud privilege to extend a cordial and respectful welcome to our distinguished keynote speaker, Dr. Arun K. Prasad, Scientist F, Indira Gandhi Center for Atomic Research, IGCAR, Kalpakkam. We are truly honored by your esteemed presence, sir. Welcome you, sir. I also extend my warm and respectful welcome to another distinguished keynote speaker, Dr. Mahesh, Gopal, Department of Mechanical Engineering, Wollega University, Ethiopia, who has gracefully accepted our invitation in absentia. So in his absence, I welcome Mahesh Gopal. I respectfully welcome our esteemed principal, Dr. S. Selva Perumal, who is presiding over this August gathering. We are privileged to have your inspiring leadership, sir. Welcome you, sir. I take great pleasure in extending my heartfelt welcome to our esteemed session chairs, Dr. N. Ashok Kumar, Professor, Mechanical Engineering, National Institute of Technology, Tiruchirappalli, Dr. M. Marikannan, Professor, Government College of Engineering, Edo, and Dr. S. Venkatesan, Associate Professor, Alagappa Chettiar Government College of Engineering and Technology, Karaikudi, who have gracefully accepted our invitation and are here to grace this occasion with their valuable presence. We are honored to have you all with us, sir. Welcome you all, sir. I extend my sincere appreciation and gratitude to the organizing committee members, heads of various departments, teaching and non-teaching staff members, and all contributors whose unwavering dedication, meticulous planning, and tireless efforts have made this conference a grand success. I also extend a hearty welcome to all the participants and who have joined us from various institutions, and your enthusiastic participation and scholarly contributions will undoubtedly enhance the quality of this conference. May this conference serve as a vibrant platform for intellectual exchange, innovative thinking, and meaningful collaboration, paving the way for transformative advancements in engineering and technology. So once again, I extend my warmest welcome to everyone and wish you all a highly productive, intellectually stimulating, and enriching conference experience. Thank you. Once again, I welcome you all.
Thank you, madam, for your gracious words of welcome, setting the perfect tone for this occasion. Thank you, madam.
Guidance from visionary leadership paves the way for meaningful endeavors. It is now my proud privilege to invite Dr. S. Selva Perumal, Principal of NPR College of Engineering and Technology and Patron of ICSIET 2026 to deliver the presidential address.
Very good morning to one and all present here. Today we have all gathered here for the inaugural function of International Conference on Smart Innovations in Engineering and Technology, ICSIET 2026, organized by all UG departments of our NPR College of Engineering and Technology. So on this special occasion, I wholeheartedly welcome to the resource persons, chief of this committee, who has more than 2 decades of teaching experience and published more research papers in reputed journals. And also, I would like to congratulate and appreciate Professor T. Balasubramanian, HOD Mechanical, and Mr. C. Kalpana, HOD IT.
Mechanical Engineering. I am coordinator of ICSIET 2026 to introduce our distinguished keynote speaker.
Good morning to all present here. It is my great honor and privilege to introduce our distinguished keynote speaker, Dr. Arun K. Prasad. Dr. Arun K. Prasad is currently serving as Scientific Officer F in the Sensor Development Sections, Material Science Group at Indira Gandhi Center for Atomic Research. He is also an Assistant Professor in Physical Science at Homi Bhabha National Institute. He completed his B.Tech with distinctions in Chemical and Electrochemical Engineering from Central Electrochemical Research Institute, Karaikudi. He then pursued his Master of Science and PhD in Material Science and Engineering from Stony Brook University, New York, both with distinctions. He has also carried out postdoctoral research at renowned institutions in the United States. Dr. Arun K. Prasad is a recipient of the prestigious KS Krishnan Research Associateship and joined IGCAR in 2008. His research expertise lies in these fabrications, characterizations, and testing of semiconductor metal oxides, thin films, and nanostructures for gas sensing applications. He has published more than 75 research articles in reputed peer-reviewed journals and has delivered numerous invited lectures at national and international conferences. An accomplished researcher, dedicated teacher, and inspiring mentor, Dr. Prasad has guided several postgraduate and doctorate scholars. His passion for scientific innovation and academic excellence continues to motivate young researchers across the country. Beyond the academics, he is a strong advocate to fitness and holistic well-being, actively promoting a healthy lifestyle through long-distance running and community sports initiatives. We are truly privileged to have such an eminent scientist and academician with us today. Ladies and gentlemen, please join me to warmly welcoming our esteemed keynote speaker, Dr. Arun K. Prasad. Following the inspiring distinguished, it's now my great pleasure to introduce another eminent personality who graciously joined us today by online. Dr. Mahesh Gopal is a distinguished academician, accomplished research, and internationally acclaimed expert in the field of mechanical engineering. He is currently serving as Associate Professor in the Department of Mechanical Engineering at Wollega University, Ethiopia. With more than 25 years of rich experience in teaching, research, and industries, Dr. Mahesh has made exceptional contributions to engineering education and advanced manufacturing research. He obtained his PhD in Industrial and Manufacturing Engineering from Anna University. His area of expertise include advanced manufacturing, optimization, additive manufacturing, tribology, welding, and civil engineering. He has published more than 80 research articles in reputed international journals and presented numerous papers at leading international conferences. His outstanding research contributions have earned him recognition in the global academic community. He is also an active reviewer for the several prestigious ACS and Scopus indexed journals. In addition to his academic and research accomplishment, Dr. Mahesh has played a pivotal role in curriculum development, research supervisions, and fostering innovation among students and scholars across multiple countries. We are indeed honored to have such renowned scholar and researcher among us today. Ladies and gentlemen, please join me in extending a warm welcome to Dr. Mahesh Gopal also. Thank you.
Thank you, sir, for the thoughtful introduction.
Leadership in academia shapes the direction of innovation and research. I now request Mrs. V. Sujita, HOD Computer Science Engineering, to kindly introduce the esteemed conference chair, Dr. N. Ashok Kumar, Professor Mechanical Engineering, NIT Trichy.
Good morning, everyone. It gives me immense pleasure to introduce our esteemed conference chair for today's event, Dr. N. Ashok Kumar, Professor in Department of Mechanical Engineering at National Institute of Technology, Tiruchirappalli. He completed his BE Mechanical Engineering from PSNI College of Engineering Technology, Chandigarh, and he completed his MTech in Engineering Mechanics from Indian Institute of Technology, Madras, and he earned his PhD from Ottawan Greek University, Magdeburg, Germany in 2010, where he received the prestigious distinction for his doctoral research. Before joining NIT Tiruchirappalli, he held several prestigious academic and research positions in Germany, including university lecturer, group leader, postdoctoral researcher at Ottawan Greek University, Germany. His extensive international experience has significantly enriched his contributions to both teaching and research. His areas of specialization include thermal stresses in metal quenching and casting process, solidification studies, and finite element modeling. He has successfully completed several major international R&D projects in collaboration with leading industries and organizations in Germany, Switzerland, and Austria, particularly in the areas of metal casting, cooling processes, and thermal analysis. He has an immersive research record with several publications in reputed international journals and conferences, and has presented his research work in the countries including USA, France, Italy, Poland, and Germany. His research papers have been published in reputed journals like Elsevier, Applied Thermal Engineering, Journal of Materials Processing Technology, International Journal of Mechanical Sciences, and Computational Material Science. He has also delivered invited lectures at prestigious universities such as Indian Institute of Science, Indian Institute of Technology Madras, Christ University, and PSG College of Technology. He is also a professional member of the German Material Science Society, that it reflects his active involvement in the global research community. He is also a professional member, and we are truly honored to have such distinguished academician, researcher, and mentor with us today. His global research contributions, achievements are truly inspiring. On behalf of everyone present here, I extend a warm welcome to Dr. N. Ashok Kumar sir and thank him for gracing this occasion. Thank you.
Thank you, ma'am. Next, I now request Mrs. J. Priska Mary, HOD of AIDS, to introduce the conference chair, Dr. M. Marikanan, Professor, CSE, Government College of Engineering, Erode.
Good morning, everyone. It is great privilege and honor to introduce our esteemed conference session chair for today's event, Dr. M. Marikanan, currently serving as a professor in Department of Computer Science and Engineering, Government College of Engineering, Erode. Dr. M. Marikanan completed his Master of Engineering in Computer Science and Engineering from College of Engineering, India, and later obtained his PhD in Computer Science and Engineering from College of Engineering, Guindy, Anna University. His outstanding 26 years of teaching experience, and his areas of specialization include database security, wireless sensor networks, and software engineering, and he has published 35 journal papers, various conference papers, and he has also authored books. And he has served as a reviewer for several prestigious international conferences and journals, including IEEE sponsored ICCCI conferences and Elsevier journals, and many reputed international publications. He has also contributed significantly in academic and government advisory roles as a Board of Studies member, Anna University examiner, inspection committee member, and coordinator for initiatives under ICT Academy of Tamil Nadu and the National Institute of Electronics and Information Technology. We are truly delighted to welcome such a distinguished researcher, author, mentor, and academician. His presence today is an inspiration to all of us. On behalf of NPR College of Engineering and Technology, I extend a warm welcome to Dr. M. Marikanan sir. Thank you.
Thank you, ma'am. Next, I would like to invite Mrs. S. Umugultum Nachia, HOD, AI and ML, to introduce the esteemed conference chair, Dr. S. Venkatesan, Associate Professor of EEE, Alagappa Chettiar College of Engineering and Technology.
A happy morning to one and all present here. Innovation distinguishes between a leader and a follower. A powerful reminder by Steve Jobs that perfectly captures the spirit of this gathering. It gives me immense pleasure to welcome you all to the International Conference on Smart Innovations in Engineering and Technology, a platform that brings together brilliant minds, researchers, academicians, and industry experts from across the globe to share ideas, foster collaboration, and drive technological advancements. In an era where innovation shapes the future, conferences like this plays a crucial role in bridging research and real-world applications, inspiring breakthroughs in smart engineering solutions. Research is creating new knowledge, And today, we are privileged to be guided by a leader who exemplifies this philosophy. Education is not the learning of facts, but the training of the mind of think. A thought that truly reflects the journey of our distinguished chair today. It's my great honor to introduce Dr. S. Venkatesan, an eminent academician and researcher in the field of electrical and electronics engineering. He serves as a professor in the Department of EEE at Alahappa Chettiar Government College of Engineering and Technology, Karaikudi. Excellence is a continuous process and not an accident. And Dr. Venkatesan's career stands as a witness to this idea. With over 21 years of teaching and research experience, he has consistently contributed to shaping young engineers and advancing technological research. He holds a PhD in power electronics and drives from Anna University, Chennai, and his areas of expertise include power electronics, electric drives, renewable energy systems, and electric vehicles. His research work, particularly in solar PV systems and power converters, that has been published in reputed international journals, including IEEE and elsewhere. A good teacher can inspire hope, ignite imagination, and instill a love of learning. Dr. Venkatesan embodies all these qualities through his dedication to teaching, mentoring PhD scholars, and guiding numerous student projects. He has also played key roles in curriculum development, laboratory establishment, faculty development programs, and national level technical events, making him a pillar of academic excellence in his institution. Today, as a conference chair, his vision and leadership continue to drive the success of this prestigious event. Let us extend a warm and hearty welcome to Dr. S. Venkatesan, sir. Thank you.
Thank you, ma'am, for presenting the distinguished profile of our conference chair.
Recognition is the sincerest form of appreciation. May I now request the dignitaries to kindly proceed with the honoring our esteemed guest, whose presence today has elevated the stature of this conference. I would like to invite Dr. S. Selvaperumal, Principal NPRCET, to honor Dr. Arun K. Prasad, Scientist F. Indira Gandhi Center of Atomic Research, Kalpakkam. Next, I invite Mr. D. Balasubramanian, HOD Mechanical Engineering, to honor Dr. N. Ashok Kumar, Professor Mechanical Engineering, NIT Tiruchirappalli. Next, I invite Mr. C. Vijay Kumar, HOD Civil Engineering Department, to honor Mr. Dr. M. Manika Marikandan, Professor CSC, Government College of Engineering, Erode. Next, I invite Dr. S. Prakash, HOD EEE, to honor Dr. S. Venkatesan, Associate Professor EEE, Aurangabad Government College of Engineering and Technology, Karaikudi. Thank you, dignitaries.
Knowledge shared is knowledge multiplied. It is now time for the formal release of the conference proceedings. May I request our dignitaries to kindly release the proceedings. Thank you, dignitaries, for marking this significant milestone.
Wisdom shared by eminent personalities enriches every scholarly gathering. I now take immense pleasure in inviting our distinguished guests to offer their felicitation address. At first, I would like to welcome Dr. Arun K. Prasad, Senior Scientist here, Indira Gandhi Center of Atomic Research, Kalpaka. Please, sir.
Hello. Okay, good morning to all of you. Smart innovations in engineering and technology. This is already an innovation for me. So far, whatever conferences or talks I have attended is only for one particular area, discipline. And then I see here, it's all undergraduate, all degrees are there put together in this. So even addressing such a gathering becomes slightly tricky, difficult. But the topics in this one is really interesting, and I hope that you get the right knowledge from everyone. So all of you are in for a big treat, and I already see you guys are way ahead, because when I was growing, never had such an interaction between like several groups. So you already have that handshake. So you are already way ahead of us. So please see and listen to all the talks with great interest and see how you can apply it in your life. I'll return back to my talk later on, but this is just a brief introduction. I would like to give my gratitude to Dr. Silaparmal sir for inviting me here. I thank the organizers for organizing such a great conference. I already see this is a success, and I see a lot of youngsters eager to listen and learn. So all the best to all of you. Thank you.
Next, I would like to welcome our respected conference chair, Dr. N. Ashok Kumar, Professor, Mechanical Engineering Department, NIT, Tiruchirappalli. Please, sir.
So good morning to all. It's good to see the events, I would say. So after a long time, this wonderful technical meeting. So I could see the from the yeah. So nowadays that we interacted with the next gen will coming. So I was surprised. So even the students from the very beginning, from the second year onwards, I think that's from the second year. So that they start learning from doing. This is something new. So even in our institute, we didn't see that kind of thing. But only in the Baha competition, we built our own vehicle. So we participated. I am the faculty advisor for the. I don't know whether you heard because majority are from computer science. So this year we participated in indoor competition. So that's what doing by the designing every components, and we still struggle to build the all-terrain vehicle. So from that I have the experience. So designing is not an easy thing, and nowadays that some of the students are learning from doing. So it is a good improvement. So I think so only gaining a theory knowledge is also a mental block, and doing that means practically learning is a new way of thing that I think the students will shine up in future in the industrial oriented problems. So I don't want to take much time. So once again, I thank all of you for inviting me to participate in this. Thank you.
Thank you, sir. I feel honored to invite our distinguished conference chair, Dr. M. Marikannan, Professor CSE, Government College of Engineering, Erode. Please, sir.
So, distinguished Principal Dr. Selva Perumal sir, respected members of the organizing teams, esteemed faculty members, delegates from various institutions across Tamil Nadu as well as other states too, and my dear friends and students. Very good morning to one and all person here. So it gives me immense pleasure to stand before you as a session chair for this wonderful international conference. But before arriving to dais, Principal sir requests you kindly deliver 2 minutes speech. I don't know what I can discuss. But anyhow, the way in which you organize this conference, especially in arrangements, as well as the way of behaving the students and inside the hall, how they are maintaining their silence, everything seems to be very nice and excellent. In this occasion, organizing team for this international conference, right? But I used to quote 2 powerful thoughts regarding this any conference session when I deliver. So point number 1, knowledge has no boundaries, only opportunities to connect, learn and transform. Am I right? So you have to connect with the team, with the specific domain, then you have to learn. What you learn, you have to transform to as a innovative projects or some outcome of the implementation part. So this is the way we have to encourage the students for their effective presentations, right? So also I would like to share 3 key terms from the students' point of view. Point number 1, knowledge sharing. Second one, hesitation. So I think most of the students were not yet started their presentations or even handling the seminar in class. So hesitation is the first failure for your improvement in your career. So various reasons for hesitations. I'm right. So main thing is fearness or nervousness. If you are presenting some, may feel somewhat, or they are using commendable words, so that they are hesitate to come forward. So avoid this hesitation. Another one is lack of communications. So the lack of communication not only in language level, though some of the students having technically sound, but they are not in position to deliver in this stage. Right? Even I am also coming from the government school student. I completed up to +2. In government schools only I completed. Then again I joined in government college as well as PG and PhD also. So initially I faced a lot of difficulties. I never handled the seminar in my UG programs. But later on, just for example, I would like to point out. So one professor forced me to engage the seminar classes. That time I didn't discuss anything, just I have written. Still I can remember. It's a compiler subject. Phases of compiler is my topic. I turned towards the board. I completely draw the diagram for phases, 7 phases. Then I have written all the points inside the stage. This is my first experience. But later on, I come forward and present so many papers. Right? So in that way, I grown up, and today I am standing before you as a session chair in this wonderful international conference. So don't hesitate. Try to improve your communication skills and try to have knowledge sharing. Right? The main objective of conference, knowledge sharing. So today I have seen your conference theme, smart innovations in engineering and technology. But everyone knows what is innovation. You are finding some concept, new concept, or you are going to incorporate into the particular project level. When you say can you, it's a smart. But I hope all are having phone. So all are having only smartphone. How do you say it is a smartphone? Right? So actually I don't want to ask any questions. Anyone can say why your mobile phone is called as smartphone with respect to any parameter. Anyone? Why do you say it's a smart? From your mobile. You can connect to the internet, point number 1, basic things. Right? You can browse websites as well as you can do all online services. You can running the apps. Again, one more thing, using sensors and automation also. Right? GPS and all other fingerprint, face lock and unlock. So everything you can provide with the help of this smartphone facilities. Right? These are the advancements in our current scenario. So you try to concentrate on the recent trends for irrespective of any branch students. Right? You try to learn and improve in your future career. So once again, I would like to appreciate the organizing team for providing this wonderful creations, as well as may this conference be a very successful one. And once again, I thank for giving me this opportunity. Thank you.
Thank you, sir, for your wonderful motivation. I feel honored to invite our distinguished conference chair, Dr. S. Venkatesan, Associate Professor EEE, Alagapachidiyar Government College of Engineering and Technology, Karaikudi.
It's good morning to all. Before I start, first with principal permissions, I need to convey thanks and congratulations to the management, particularly principal sir. Regarding that, of course, 50% women's reservations, still it is going on, still it is fighting on that parliament itself. Whereas I came to hear all HODs and of course in this stage also organizing committee சார் பணம் சேர்க்கிறாங்கிறதுக்காண்டி 4 பேர் ஜென்ஸாக போட்டுருக்காங்கன்னு நினைக்கிறேன். I think so. For that, first I congratulate the management and the principal. Distinguished guests and the respected principals, head of the departments, esteemed professors and honored speakers, and dear participants and students, good morning to all. It is both an honor and privilege to stand before you today as the chairperson of the Electrical and Electronic Streams at the International Conference on Smart Innovation in Engineering and Technologies. Of course, this gathering represents not just an exchange of ideas, but a convergence of vision, creativity, and the technological progress that will shape the future of our world. The field of electrical and electronics engineering has always been at the forefront of innovation. Today, as we move deeper into the era of smart system, artificial intelligence, renewable energy, and the interconnected systems, our discipline plays a critical role in enabling sustainable and intelligent solutions. This conference serves as a dynamic platform for the researchers and academicians and the industrial professional to share cutting-edge development, discuss emerging challenges, and explore collaborative opportunities. As engineers and researchers, we carry the responsibility for ensuring that our innovation contribute positively to the society and address real-world problems. I would like to extend my sincere appreciation to all the authors and participants for their valuable contributions. Your research and insights are the driving force behind the success of this conference. I also thank the organizing committee for their dedication and meticulous effort in making this event reality. Finally, this quote I conclude: success begins with a strong base. Success begins with a strong base. Build your basics and the excellence will follow. Build your basics and the excellence will follow. Once again, I warmly welcome you all this conference. I hope this conference brings you valuable insight, meaningful discussions, and inspiration. Thank you. Thank you.
Thank you, esteemed speakers, for enlightening and thought-provoking words. The keynote address stands as intellectual cornerstone of any conference. It is now my distinct honor to invite Dr. Arun K. Prasad, Scientist of Indira Gandhi Center of Atomic Research, Kalpakkam, to deliver the keynote address. Welcome you, sir.
என்ன போயிட்டு இருக்குன்னு பார்க்குறேன். தேடிட்டு இருந்தேன்.
ரெடி பண்ணிட்டு
Triple and mechanical. And I don't know any of them. And civil. Okay. Civil. And I don't know any of them. So would it be useful to you students? And how can you make it relatable? So usually I've given innovative talks only technical. If I give that talk, I see already all of you are asleep in the last few rows and you not even have had tea. So I thought I'll make it kind of like general talk. Okay, there will not be technical thing. It will be a general thing which everyone can relate to, no matter what a discipline is. So I tried to put. I think I gave the talk only yesterday only after I saw the flyer and everything. I tried to put together. This is also the first time I'm giving such a talk in open audience. I had actually some of it in some talks, but not a general talk like this. But I hope it will be useful for you. So I tell my talk advanced materials, which is what I do, and technologies for sustainable future. So I'll be talking some about some materials development, which is what I do, and how it can be interdisciplinary. As I said earlier in the short talk, you require a handshake. When we were growing up, we didn't have such a handshake between departments. Now somebody was talking about drone. You know, like we all know drone is like a small children's play toy. That's what we grew up like learning. But now drone is used for several other applications. So how do you apply a particular technology to some other thing? So you need a handshake. Okay, between like CS, and electronics, and then like data science, and then like security, everything's involved. So you can't just say, I'll only do this and then I will try to succeed in life. No, it's not going to happen now. The life which we grew up is not the life which we are going to be facing. And particularly all you youngsters, you're already smart. Okay, you know a lot of stuff which I don't know. Okay, so but with that knowledge, how can you apply? That is what I will try to address here. So I'll talk about advanced materials as I said, and then technologies for sustainable future. Okay. So as you all know, I'm actually hailing from Kalpakkam. So have you? How many of you have heard about Kalpakkam? 1, 2, 3, 4. A few students. Okay. From student side, recently Kalpakkam was in news. Do you know what for? Yes. See, don't feel shy. Even if you're wrong, it's fine. Even I also sat one some few years back. Yeah. PFBR. Yes. So what is the expansion of the PFBR? Read reactor. So what does it do and why was it in news?
So it's a technology that was created to that's in stage 2 actually. So you generate more energy than it consumes.
You generate more energy or you generate more fuel?
More fuel.
More fuel. Okay. I'll talk about the reactors, what we do. That will be something new to you, right? You'll be interested in learning about reactors a little bit, but I'll not go into the details. I'm not supposed to go into the details, but I'll just say briefly. Kalpakkam is the land of fast reactors. Okay, we have reactors everywhere all over the world, nothing new in India. But Kalpakkam has a unique place in India. It is a land of fast reactors. The only 2 fast reactors in India are here, Kalpakkam. Okay? You said it rightly. Who was the student who said PFBR? So what is new about that one?
Actually, only 2 countries in the world currently have.
Yes, correct. Yes. But why is it in news of late?
Because India is large, 25% of the world's total.
That is fine. But why still you have? Why was it in news? I'll tell you. Okay, it's fine. Okay, you got the answer, right? We means India. Okay, we have built the first fast breeder reactor. These are the only 2 fast breeder reactors available in India. Okay, the first one is actually a fast breeder test reactor, which means you put in something, see if it works. If it doesn't, you remove, you put in something else, you see. So you do some test and see if it can generate electricity. Okay, that. And we usually did, the reason it's in news because The latest one, the prototype fast breeder reactor, it went critical. So when you said this building was built in the year so and so, it stops with that. But for a reactor, it is not so. The reactor was built long back, but it doesn't gain prominence. It only gains prominence for the reactors when it went critical. Okay, I'll come to that in a little while. But this one, it's still been running. 1985, all these reactors are usually built for 40-45 years. And here, so here the main aim was not to generate electricity, but to show that we can generate electricity and to do some tests for different reactor materials or fuels, and to show to the world we can operate a fast reactor. Okay? And here recently on 6th April, this month, this PFBR went critical. You might know our Honorable Prime Minister, he came last year to initiate the fuel loading. So as far as the reactor is concerned, it's not the date it was built which is of importance. It is the date on which it went critical. Okay? For humans, it is not a good thing. If suppose somebody says you are critical in health or the way you speak is critical, it's not a good thing. But for a reactor, it's a good thing. So how many of you know what a criticality of a reactor is? Okay. Okay. So I have something new to talk about to you. Okay. But see, all these things, it might not be directly related to you, but try to find some link how you can apply your knowledge to this reactor, because as I said, it requires a handshake. It's not one particular discipline which runs a reactor. Right from civil to everything, engineering, VCE, you take all disciplines of engineering are involved in running a reactor. Okay? So you might have learned this in your schooling days. What is a nuclear reaction? Is when a neutron, a slow neutron, interacts with a fissile molecule like uranium-235. Okay, it splits into two new elements. Barium and krypton is what we have read, but that is only one of the possibilities. You have a wide range of possibilities, but barium and krypton they usually say. And it releases 3 more neutrons. So all these neutrons are all like fast neutrons. So what do you mean by fast neutrons? It's just the energy at which it is released. If it's slow moving neutron, fast moving neutron. So all the reactors all around the world, they run on slow neutrons. Okay, why? Because that gives it an extra chance for it to create a reaction. If it is too fast, it just doesn't seed the atom. Okay, but we will go to that later a little bit. Okay, and these neutrons, they go and hit subsequent uranium atoms, producing a chain reaction. Okay, so you start from 1, it hits the uranium, it produces 3 neutrons, that goes and hits subsequent uranium atom, produces 3 more. So it just goes off exponentially. If you don't have a way to control that, it leads to a bomb. And no, we don't do bombs in Kalpaka. Okay? So make sure that, because they even ask me, do you make bombs in Kalpaka? No, we don't. All reactors, nuclear reactors worldwide are controlled fission reactors. So what we do by control is, we control the number of neutrons which are released. So here you have 3 neutrons, we have something called as absorber rods. That absorbs the neutrons. It doesn't allow the further reaction to happen. But if you have too much of the rods, there will be no reaction. That stage is called as subcritical. So you have the fuel, you have the neutrons, it is generating subsequent neutrons, but it is not going and generating subsequent fission. That stage is called subcritical, which is of no use. Okay, it doesn't generate electricity. Then supercritical is what I said. If you don't have any controllers, it goes subsequent like uncontrollable Nagasaki, Hiroshima kind of things happen. That also we don't want. We want something in which we can control the number of neutrons. See, here is really simplistic. Okay, one atom gives you 3 neutrons, but inside an actual thing you have several grams of uranium. I will say kilograms, it says grams of uranium, and it has so many atoms. So how do you design that? So for every reaction you should have at least 1.06, some fraction is there. So to achieve that level, so you have to adjust the rod depth to see if you can sustain the reaction so that it doesn't go out of. So if you want to stop it, you can stop it, but it should generate sufficient heat. So how does a nuclear reactor generate electricity? Maybe next question. Simple. How does the normal traditional way of generating electricity through coal? Okay, they heat up coal, they produce the heat, they use the heat to make steam out of water. Steam is used to rotate the turbines that generates electricity. Okay, same thing. We use, instead of coal, we use nuclear heat. Okay, the heat generated by these fast-moving fission products that is transferred to the system. That system is again transferred to water to produce steam. Steam will rotate to turbine and will produce electricity. So, in April, on April 6th, we have achieved the criticality. So we know exactly now, if you want to shut down a reaction, we will, if you want to allow it to go supercritical, it will not allow you. That is the AERB regulations which we have, the Atomic Energy Regulatory Board. So you cannot go to your home and start building a nuclear and then create a bomb. It's not going to happen. So even for reactors, we need to get prior approvals to run a reactor. So now we have achieved the criticality. Now we can start generating around 500 megawatt electrical. Okay, there is this efficiencies there, from steam to electricity. That's conversion ratios there. See, here is only really small. As I said, this was not to produce electricity, but to show that we can. And here is what will be subsequently. It will be built in India, the second generation reactor. I'm going to talk about that later on, but I just wanted you to know where I am from and everything. So I am from the land of fast reactors and nuclear reactors. You should know that. So you don't need to be afraid of nuclear reactors in places like all these places, Kalpakam. Everything. Okay, now I go to my talk. Okay, so now how do I make my talk relatable to all of you? It's a bit tricky. It's still a challenge, but I'll try to do as much as I can. I gave this talk in one of my labs once. So I'll try to link climate, energy, and sensors. Okay, so climate is what everyone has to face. Okay. The energy, the whole thing, all the innovations in all these 3 areas. How do you achieve new materials as well as advanced technology? And sensors is what I do in my lab. So I also talk about that in the end. But let's see, it's actually interrupting again. It's again a handshake. So I divided my talk into 3 parts: the climate, the energy, and sensors. So what is climate change? You all know if there is a rise in the CO2 levels in the atmosphere, it leads to a rise in the temperature. Why? Because it goes and blocks the heat from being released out to the upper atmosphere, and hence there will be global warming. So they have several UN climate change conferences happening, and then our Prime Minister he had said net zero carbon emission by 2070. Means you have to shift from the non-fossil fuels to non-fossil fuels. And we have to generate 500 gigawatt of non-fossil energy. So how does one achieve that? Okay, so all this is required for the climate, and that you can see is again linked to the energy production. Then COP27 outcome is one of the things is methane emission. Why? Because it is the second largest producer of heat after CO2. So you have CO2 and you have CH4, and we need sensors for them, and that's what we are doing. Okay, so again you can see there is an interlinking between all three. And all the subsequent ones, you can see fossil fuel, and then the triple renewable energy, and then for green world. So all, I think you might have heard about green everywhere, right? The latest one also, which happened last November, to go away from fossil fuels. So what is the carbon footprint and how do you reduce it? Okay, how do you reduce the CO2 levels? So you can, so the CO2, if you know the sources from where it is released, you can try to address them. Okay, first, the most important contributors from industries. Okay, then you have the electricity and heat generation from plants, nuclear power plant, other plants, buildings, the agriculture, the other energy, transportation, waste, everything. Okay, so all these places you have the release of CO2. How do you reduce them? You again have a recipe how to reduce the CO2 levels. You can live car free or use electric cars, electric vehicles, one less long haul, and the use of renewable energy, which I'll be talking about again. Public transport, lot of things, But all the things you can, it's easier said than done. It's easy to preach from here, but to actually implement them is really hard. So I'll just go to one particular example, renewable energy. Okay. So for that, I go to the second part of my topic, which is energy. Okay. First, we should know what are all the energy sources available and what alternatives we have. So the first one, as I said, is from coal. Largest producer all over, not just in India, all over the world. Wind energy, petroleum, hydropower, solar, geothermal, hydrogen. Now hydrogen is next big thing. Okay. The hydrogen fuel cells and everything. Natural gas and the biomass. And nuclear, of course. Okay. So I will focus about on these red circles, only natural gas, hydrogen, biomass, and uranium, or the nuclear part. So natural gas, is 95% methane. It's obtained from deep, drilling, gas with shale. It's a fossil fuel, so it's not renewable as such. But the problem is not just that. The next one is from biomass, wherein you have degradation by algae of wood, bioenergy gases, and then you can obtain ethanol, bioethanol, ethanol blended gas, and biodiesels. So all these is just advanced kind of technologies for conversion from biomass to how can you make it into fuel. We also have from our this Baba Atomic Research from nuclear energy. We also do such. We have human waste, or also everyday domestic use will be waste which we throw out. From that, we can put it in a mixer and then through aerobic heater, thermophilic and subsequent anaerobic digestion, we can produce CH4, which is used as a fuel. Okay, and with this, they have provided electricity to several villages in and around Mumbai. And it's also not only in Mumbai, some places even in Tamil Nadu also, they have transferred this technology so that you can actually utilize them. But the use of methane as fuel, is it justified? No, because it is the second largest producer of the greenhouse emission after CO2. It's 85 times more potent than CO2 in trapping the heat, and methane is again it is cracked to CO2. So you subsequently produce a lot more CO2 than you actually start from. So what's the alternative? Okay, now of late hydrogen is actually picking up, and nuclear for green energy. So you see latest last year budget and there have been a lot of allocations for nuclear energy. So let me first start with hydrogen, then we'll go to nuclear. So hydrogen as how do you use it as fuel? It's really simple. Hydrogen interacts with water, produces H2O. No harmful CO2, no harmful CH4, nothing. And this reaction produces a lot of energy as well as it generates electricity. Simple. So a lot of research is actually going on right now in fabrication of such fuel cells and how to improve the efficiency. So the hydrogen has to be cracked to atomic hydrogen and that has to interact with oxygen, with water. And how do you produce this hydrogen is the next big thing. And the hydrogen can also be directly used as like fuel, like petrol or diesel to produce energy. So we can also use hydrogen enabled with gas, like automobiles are also there. So the problem is hydrogen is not freely available in air. The availability of hydrogen in air is only a few ppm, parts per million. So it's not freely available like nitrogen and oxygen. So you need to generate it from somewhere. That somewhere is from water, electrolysis. So you split water, you store the hydrogen, and you use them when you need it. Okay? So that's the whole idea. So by this water by being liquid, it's of no use. So you need to split it into hydrogen. You have to store it. You can transport it also. So that's where the hydrogen leaks for hydrogen sensors and all are required for that. That's what again we do. Yeah, the transportation, as I said earlier, it's also used in transportation fuel, industrial, like energy use also in several places instead of other organizations. Now they are actually using hydrogen. I'll show these in the next few slides. So the advantages of using hydrogen is actually like zero emissions at the point of use, high energy per unit mass, and it versatile. It can be used as electricity plus heat plus fuel. But the problem is it's really light, so you need like sensors to see if there is any leak, and it's really expensive to produce hydrogen. Like green hydrogen, you should produce again, not using the harmful waste to produce hydrogen. So you can see that the hydrogen is something that is battery which you can use anytime you want to produce energy. So hydrogen, they have several ways. They have coding of the hydrogen based on how it is actually like generated. As I said earlier, actually the naturally occurring hydrogen is less than 1 ppm in the whole atmosphere. So that we really cannot use. So we need to produce hydrogen to use it as a fuel, to use it as a green fuel. What I'll be focusing again is on how to generate hydrogen from nuclear power. Okay, it's again by hydraulic splitting again by using the heat generated in the nuclear reactor. Okay, if you see other ways, like solar electrolysis, these are called yellow hydrogen, blue hydrogen, gray hydrogen is where you have a lot of CO2 release. Here you can actually you can store the CO2 and use it for subsequent uses. So there are certain classifications. So which of them are the safest and cleanest sources of energy? So if you see the safest point of view, you see so many deaths and accidents because of coal is really high, and the amount of greenhouse emissions is also high. But still, they don't stop it. Why? There are a lot of like geopolitical things involved in it. Because if you say I'm going to start a reactor, Kodangula, for example, the great example. When they started the Kodangula, the locals protested. Why? Because those who are working in the normal power plants will lose their job. Though they know these are all really harmful, and then you have a lot of greenhouse emissions, they want the livelihood to be secure. So they just created some unrest, and then they had it on hold for a long time. And further to the point that technology was supplied by Russia, and then we all know about the Russian nuclear reactors, so they got really afraid. There is nothing to actually like worry about that. Now we know about that later on. Then next one is oil. Natural gas again. You can see greenhouse emissions. If you see nuclear, it's really small. For the same amount of electricity generated, and also the number of deaths if you see from nuclear reaction worldwide, not just in India, worldwide, is 0.03 per 1,00,000 people. So it's really a small fraction, but they make it like appear as if it's really, it gives you the explosion, radiation, everything. So it's all false like information. Like another way to look at it is, see, if you want to generate 50,000 kilowatt hour of electricity by coal, you see how much amount of coal you require. You can see trains of coal like running on tracks every day. But the same amount of energy, if you use uranium, you can just achieve it 1 kg. So whereas 1 kg and whereas 50,000 kg. Okay? And also you can use the heat to generate hydrogen. It produces clean energy, no harmful, actually like toxic CO2, CH4 are released. So now, to answer that question, so what is the India's like 3-stage nuclear program? So we know we need to go for nuclear now because it's really, and why India has to go for nuclear? Why, when several other countries have already started, why India has to go through it? I think you answered the question. India has the 4th largest. Huh? Yes, correct. So I'll reach that. Okay. So why we need to go for a nuclear reactor was something which was envisaged by Dr. Homi J. Bhabha, who is father of Indian nuclear, the whole science and everything. He said that there are only three fissile atoms worldwide which are used in nuclear reactors which produce electricity. One is uranium-235, one is plutonium-239, other one is uranium-233. Okay, so all over the world, what we have is we're using uranium-238 and 235. U-238 is not fissile. Nothing will happen if you handle it. U-235 is fissile, but it's only a small fraction in natural uranium, and India doesn't have enough of it. That's why we're talking about drones for exploration of mines to locate uranium resources in India. So what we do, we have built pressurized heavy water reactors. Around 25 of them are there in India, right now as we speak, in 6 locations. So that generates electricity. But that is not important for us. That actually it produces plutonium as a byproduct. That plutonium, we are using it in the 2nd stage, which is the PFBR. Okay, you think of it like this. You are going to make some aloo for the night. Okay, you're going to make it's potato. Okay, you want to make some dish from a potato in the night. Instead of having to boil potato at night, what in the early ages what they used to do is they used to put the potatoes during lunchtime around the rice when they make the rice. So that they don't have to use twice the amount of energy. You cannot use raw potatoes, so you can put potatoes around the rice. So potatoes will be cooked. You take it aside and then you put it for the night. That is exactly what we're doing over here. This plutonium, how do you say it's actually a breeder reactor? You put in thorium, which India has a lot of. Okay, that you put around the reactor, wherein you have plutonium which is generating electricity, and that gives, we use thorium, which is U-233 as a next fuel. So you put in something which is not a fuel, but you end up with something which is having a lot more fuel. That is the breeder reactor. So it produces a lot more plutonium than what you started with. Okay, and this stage, you have to go in for the next stage. The thorium is available in the beach sands all around the east coast, west coast, level places it's there. You see black layers sand. Very recently I went to Varkala beach. They had this black sand beach. All those are all of this type of this monazite ore. Okay, so that from that you can get uranium-233. That is used in the last generation reactor. So we don't have enough uranium, so we have to import it. Using that, we produce plutonium, which we can do some more breeding. And using this breeding, you can convert thorium into uranium-233. This is the whole three-stage program of the Indian nuclear program. This is again what he said. India has one of the largest resources of thorium, and I'm also proud to say that Kalpakam is the only place wherein we have reactors of all three generations. We have this MAPS reactor, which has been running from 1972, which is a PHW reactor, which is the first stage. From that we get the plutonium, which we are using for PFPR, and that we also have a small kind of a test reactor inside. Which is based on the U-233. So we have all three generations, the only place the whole world, not just India, but the whole world. We have all three generations in one place. Okay, so what is it is that after Russia, India is the only nation which has been able to demonstrate the fast reactor technology at such a big scale. And what I want to highlight is this one, after decades of failure. Okay, so when you start something, of course, you shouldn't be afraid of failures. Okay, that is one lesson. And we chose survival over comfort. We could have easily left it. So many have tried, they have failed. Well, why we should even try? Because we know that we have largest resources of thorium, which if we don't use something, nobody is going to use it. So we needed to go to the last stage to use it to build reactors. Then again, with respect to radiation, there's something which people usually ask when you talk about nuclear reactors: is it safe? Is there a lot of radiation around the site? Because we get asked every day. The background radiation, like right now over here, is around 2.4 millisievert. Okay, you just don't worry. It's actually unit of radiation dose on humans. So natural, like in a place like here, natural background will be around 2.4 millisievert. And what we produce from from nuclear power plant, from the extrusion zone, we have about 1 kilometer radius, then 3 kilometers, then 5. So like that we have, if you see in all the 6 sites, it's only 40. It's microsievert, 1,000 times smaller than what is naturally available over here. So the naturally occurring radiation is from several things, which is like uranium, and also a lot of other like thorium. So all the which are naturally available, and also radon, radium, which there like is bricks and all, it's there. You just don't see it, but that level is so small. But for humans to get affected, so you need around 500 millisievert to see the first sign of radiation effect. It is way above than what we are dealing with over here. Even if you go for a CT scan, that itself will produce 7 millisievert. That is way above than the background. Okay, and we can see the sites on all the other sites. You can see the radiation is practically nil. So I'll come to the last part. About sensors, why they are used. We also have like detectors. When you say radiation, they should talk about alpha, beta, gamma. These 3 rays are the ones which they talk about radiation, and for that we have radiation detectors. Okay, like we have sensors, they also have detectors to detect if there is any harmful radiation into the atmosphere. So I don't talk about the detectors, I talk about the sensors. So earlier we have to know about CH4 and hydrogen. So that's what we are actually focusing on in our labs. Well, why do we need gas sensors? I don't think I have to explain this after seeing this whole amount of toxic gases released from the atmosphere, and how it is important for our human health and also later for future generations. So it comes in industrial emissions, vehicle exhaust, even from agricultural practices, open waste burning, storms, everything. I'll skip this one. We know the reason for Delhi pollution. So the need for sensors is, in all sectors it is actually useful. In the automotive sector, for NOx, O2, and the hydrogen sensors, everything is required for the research. We have Bharat standard like 3, 4, 5, all those things. It's how much amount of air is released from the vehicle. The food industry is to control mountain spoilage. And then domestic sector for like CO2 to see if you don't suffocate inside our rooms. The medical sector for diagnostics and application. Security sector for detection of explosives. In like airports or where they scan. So they also have the sensors. And nuclear power, which I said earlier. So we need to develop advanced materials to get what the sensitivity, improve sensitivity, detection and all. How much time I have? How much? 15 minutes, 10 minutes?
10 minutes.
Huh?
10 minutes.
10 minutes, okay. So progress, I'll just, okay, so all the gases, like you can see, causes so much amount of health issues for humans. And you don't even know about it. So it's like from pneumonia, the lung cancer, pulmonary diseases, stroke, everything related to the amount of gases. So what we need to work with is, there is something called exposure limits. So for each gas, we need to know something to work with. So if you say a sensor, you should first talk about the limits with which it can detect. If you have a sensor which is detecting something which you don't need a sensor for, there is no use. So we have some kind of limits, toxicity limits. So generally, they used to have a small bird to go inside the mines, and if it dies, means something harmful is there. That's how the sensors were in the olden days. Even now they use sometimes, but they even know sniffing dogs. Why dogs have actually it can sense 8 orders higher magnitude or lower magnitude of detection than humans. So that's why even dogs, even now they are used. But we have to go technical way. So we have to develop advanced materials. I don't go to this one. So how somebody was asking me, how does your sensor work? So there is a change in resistance. Okay. So when some oxygen from the atmosphere, it reacts with your sample, which can be semiconductor oxide, it forms a diffusion layer, and if you have to detect like hydrogen or methane or anything, that will re-inject back the electrons. So injecting and removing of electrons lead to a change in resistance of your sample, and that is how your sensor responds. And then we have to go to nano. One of your topics was nanoscience and nanotechnology, right? So this we do actually a lot of research in nanotechnology. So the reason is when you go smaller in size, from large size grains, when you go to small size of particles, nanomaterials, you can see the sensitivity, it goes up. When you go down in size, the sensitivity of your sensor goes up. So we can get a response immediately. It's something if you want to see there is some hydrogen there, you cannot wait for a long time for sensor to give you signal. So you need instant response. So for that we have scope for improvement of that. And we also decorate some particles like something like platinum or palladium can preferentially absorb hydrogen. So how can we decorate like platinum or palladium on our nanomaterials to improve sensitivity? This is one of the sensor setups which we have in our lab. I will not go into details of that. This again, so something if you don't want to build a big setup, you can start with something like very small. Actually, the idea is anybody, if you want to make a change in your surroundings, your lab, you can start even with something small. We started with this one, a small setup to detect alcohol sensors. Water organics you can also use for hydrogen and all. So you just need an idea that with the innovation which we are talking about, you need the innovation to see how you can implement your ideas to deliver something which is of use to the society. I'll skip these things. We have market 7, actually a lot of oxides, materials for our sensors. This is how our sensor looks like, very simple. some of the sensors. So when you actually introduce ammonia, for example, the resistance drops. So how much it drops shows how much amount of ammonia is there in the ambient. Again, like functionalization with nano particles of like gold, like if you see like here small decorations on zinc oxide, how we can reduce the operating temperature from 180 to around 100 to around 120. So you are always in search of new materials for sensors. Also, there is a lot of scope for advanced materials for like reactors also. Let's skip these things. So there is a recently I was part of a big review article of all gases and materials all around the world. So you can see it's like actually several other oxides, and I had contributed towards MO3 for gas sensors. So all the sensors which you do, you have to make sure you put it in some form which is of use to the society. You just doing research in lab is not sufficient. You need a handshake, as I said earlier. You need to talk. We are interacting with the electronics people over here. We synthesize this, put in electronics, and then these electronics. This only like an Arduino chip. This was done by one project student from Vellore Institute. Monisha. She was from a really humble background. Now she's in US doing her postdoc. So she did this one. She was actually from ECE, the background. So she we made the sensors and then she did all the interfacing to see if we can have a readable output. Okay, and so there is scope. If you want to innovate, make something new for the society, you can always do it. And we are producing a methane sensor, which we are deployed to incubation center rather. So any industry can actually take up our methane sensor and they can sell it. So we have developed this CH4 sensor. So last part, because I'm ending my talk. So how do you go towards sustainable future? I said earlier that the age which we live is not the age of you youngsters, especially, and we need to leave behind something which you can be proud of. We don't want to leave you behind a polluted world with no energy to survive. Okay, so far we have utilized all the fossil fuels gone, and when you arrive, you have no energy. So how will you survive? So we don't want to leave you in that. So how do you leave behind a sustainable future? An atmosphere free of pollution, clean air, and active surroundings. So the climate part, which I talked in the first part. Then the energy security. So you know so energy security is so important for our country, and why we need to look into other advanced technologies for energy, be it from nuclear or hydrogen or other green energies. Then we need smart sensors, which is what I'm working on, but anyone can actually start developing sensors with whatever like learning which you are having. I see a lot of in your flyer, AI, data science, everything is actually like involved. It's not different from what I've been preaching so far. For all whatever I have shown right now, we need AI. We need data science innovations. We need IoT, Internet of Things we need. We need embedded systems, smart electronics, and then robotics automation. You see about smart cities. How do you have interactive? Also, you need all this. So all these have to handshake with all these three for sustainable future. Okay, so I said in the COP, in COP26 we have actually promised 500 gigawatt. What is the energy distribution in India right now from non-fossil fuels, from renewable energies? See, wind energy, if you go to the south of Tamil Nadu, you can see so many windmills on the road. It occupies so much of space. Okay, but we already have everything installed. But again, sometimes you have wind, sometimes you don't. So how do you address that? Bioenergies. Then hydro energy, where you have dams, from there you can generate electricity. Then you have 11 gigawatt. Then solar energy. It's still there, still struggling to find a foothold in India. I mean, a lot has been invested in it, but if you see nuclear energy, it's only 8.78 gigawatt. After 25 reactors, now it has come to 9.2 after PPBR. For this, I think last budget they introduced, I think they introduced Shanti Bill. I think you have heard about Shanti Bill? No? Has anyone heard about Shanti Bill? Lok Sabha, Rajya Sabha? Okay. So far, only the government of India can build and operate nuclear reactors. Okay? But with this, we have opened it to the private players. Why? Because to build a reactor takes 15 years. It is the government of India. But something like if you have like steel industry, they require tremendous amount of electricity to run their industries. So where do they get electricity from? They are actually draining our resources. So what we give them is we give them an opportunity to build a reactor. Of course, government of India will keep the know-how. They will safeguarding AERB regulations, IEEE regulation, International Atomic Energy Association, IAEA is a whole international it's watchdog. So with that, we give something like GE, even like Adani. They are all showed interest to build reactors in India. So to find the area, the land, the acquisition will be faster if it is for like private players, and we can also have investment from abroad for materials like steel, SS, all the reactor materials, they are all SS. This one, so all those we can import from outside. So all the process will be faster. So we can achieve. We have actually promised by 2032 to have around like 25 gigawatt or something, and then by 2047 around 45, and by 2070 100 gigawatt. So how do you achieve that? Not just by our reactors, but also by something called a small modular reactor. So the Shanti Bill effectively says private players can be used for building nuclear reactors and running the reactor, but all the know-how, all the technical things inside will be handled, because those have to be in secret. Okay, we cannot reveal those things outside, whatever technology we have for our safety and security. So we have several small model. All these are already available outside. Actually, US has several small model reactors. China is already pretty ahead. We are just jumping into the bandwagon. So we have to have one small. So we have some design aspects. So for all this, BRC, IGCAR, we are all the ones who are giving support to build all these technical reactors. So, like smart cell, you have smart cities, smart sensors. You need the handshake. You have all this BS3, BBS4. Are we implementing it? How do we know it? We need sensors for them. We need the handshake. Explosive security in all these areas. You have like area monitors for radiations and everything. So a lot can be done. We have several the organizations supporting us to build in India, to make India proud. Okay. With this, I note this is my section head who has helped me all throughout. The former deck is retired now. All these are my PhD students. She has graduated and she is now in ICSIET Hyderabad. These three are my present students, and these are all from where we have project students for MS. We have 6 months projects, 3 months projects where they can do some experiments in our labs. I already talked to your principal. Sodium, it is so, it's so less used in India that we have to import it from outside. Only now that yes, we can demonstrate sodium after this FBTR, not latest one, we have started to actually to generate rather reactor grade sodium. Something like it has a grade 95.999 or 99% sodium, only so much amount of impurities is allowed. That we don't have the know-how. We did not have, but now we have. So there are a lot of things. So first one is the plutonium. Next one is handling of sodium. Next one is the reaction engineering. There is something called reactor. We have a big reactor. It's physics group which shows how you can see it's really a small fraction of the neutron. When it shows the criticality, it's 1.06. If it goes 1.05, it stops. 1.07 supercritical. How will you achieve that? Very stringent margin. So even before a reactor is built, even before you propose to build a reactor, you need to show to government or regulatory boards that with such a design, it will be safe and I can generate electricity. So that know-how is not there. That we have in 1985 we have started with this possibility reactor. It's only a small size reactor. So if anything happens, we can just shut down everything. But with such a power generating thing, we cannot do it middle at will. There are a lot of stakeholders who will start shouting. Okay, but with a small, lab scale reactor, which I see every day, So with that we can see we can optimize the fuel, the sodium, the size, the material in which the uranium or the plutonium is placed inside. All those things we can. So there are a lot of things which is required to run a fast reactor. So not only we have shown to the world, yes, but there is still a long way to go. Because with this, we have to generate sufficient fuel as was put in initially. That is the breeder reactor. So to achieve that, it might take around 12 years. That means your next reactor will be ready only after 12th year. You will have sufficient fuel for that reactor. But you start building it right now. But the fuel for that reactor will be ready after 12 years. If you are not sourcing it from some other way. So like that we go on building like NPRs or kind of fast reactors all around India. Then everyone has to agree. The governments has to agree to build in their state. All those things are there. But I would say so it's only the technological know-how. That is the challenging part, which is stopping us from going ahead.
Thank you so much.
Can you mention the areas where we can apply artificial intelligence and data science and automation?
Artificial intelligence, automation,
Data science, innovations.
Okay, I can say about automation. Okay, wherein the reactor instrumentation side we have to lift the actually fuel pins are not basic. Where say which you have uranium, you have to lift it after its use. You have to lift it, replace it by another thing. So that requires automation. You cannot, no humans can go inside. So the whole thing is secure. We can see it from outside, but we cannot go inside and handle it. So those places where you can have an automation. Artificial intelligence, maybe for modeling we can use it. For buildings like further reactors, we might need AI. But as of right now, I don't know. Data science, of course, we require wherein we need to see actually like every reactor, it has so much things happening inside which we cannot literally go inside and see. So we envisage such things would have happened inside, and we get feedback from sensors and instrumentation. So that we have a big data every day is being generated. So we can try to track the data and see if there's something off or something needs to be replaced, some repair somewhere, some leak somewhere. Those we can see data science, we can utilize data science, and the AI also I think we can utilize in the same way. But I think AI they use it like initial stage wherein you have to kind of like designing a reactor. There I think AI is required.
Thank you, sir.
Thank you, participants. Thank you, sir, for the deeply insightful and inspiring keynote that has set a remarkable direction for the proceedings ahead.
Gratitude indeed is the fairest blossom of the soul. I now invite Mrs. C. Kalpana, Head of the Department of Information Technology and Coordinator of ICSIET 2026 to propose the vote of thanks.
Respected Chief Guest, distinguished keynote speakers, esteemed conference session chairs, Honorable Principal, respected dignitaries, faculty members, students, researchers, and dear participants. A very pleasant afternoon to all. It is my proud privilege to propose vote of thanks for this inaugural session of the International Conference on Smart Innovations in Engineering and Technology, ICSIET 2026. We sincerely thank our management for their support and permission to organize the International Conference on Smart Innovations in Engineering and Technology at NPR College of Engineering and Technology. At the outset, I offer my deepest sense of gratitude to our respected principal, Dr. S. Selvaperumal, whose visionary leadership, unwavering support, and academic stewardship have been the cornerstone in organizing the prestigious international forum. His guidance continues to inspire excellence and innovation in our institution. Thank you, sir. I extend my heartfelt thanks to our eminent keynote speaker, Dr. Arun K. Prasad, Scientist F, Indira Gandhi Center for Economic Research, Kalpakkam, for delivering an insightful and intellectual, enriching keynote address. Thank you, sir. I wish to express my deepest gratitude our distinguished session chairs and distinguished chief guests, Dr. S. Mahesh Gopal, Department of Mechanical Engineering, Wollega University, Ethiopia, Dr. N. Ashok Kumar, Professor, Department of Mechanical Engineering, NIT Tiruchirappalli, Dr. M. Marikannan, Professor, Department of CSE, Government College of Engineering, Erode, Dr. S. Vengadeshan, Professor, Department of EEE, Alahappa Chettiar, Government College of Engineering, Karikudi. Your valuable presence, thought-provoking felicitation, and expert insights have truly elevated the academic stature of this conference. My sincere thanks to our esteemed conference session chair. Thank you, sir. And I would like to specially acknowledge Dr. M. Amina Banu, convener of ICSIET 2026, for the exemplary commitment, meticulous planning, and tireless efforts in ensuring the seamless execution of this conference. Thank you, ma'am. I also extend my sincere thanks to the organizing committee